Solving trig equations. So as an example, first example, let's solve this equation. Now, the cosine of x is going to follow the same rules as any variable such as x or y or whichever variable you wish. You can do the same things to equations such as this. For example, if I'm going to solve this equation, I want to get rid of the 2 cosine of x from the left-hand side, for example. So I'm going to subtract it from each side. Okay. After cancellation, then we get 1 equals twice cosine of x, and I'm going to eliminate that 2 by dividing each side by it, and cancel, cancel, and what we get is cosine of x is equal to 1/2. All right, and now we need those angles whose cosines are 1/2. And in this case, if you apply the unit circle stuff, the angles will be pi thirds and 5 pi thirds. So those are our potential solutions for this equation. But we need to check them because not always will these solutions solve the original or satisfy the original equation. So we need to check them. So I'm going to plug pi thirds in for x in here and see if the left side equals the right side. So 2 cosine of pi over 3 plus 1, 4 cosine of pi over 3. Now the cosine of pi over 3 is 1/2. Twice 1/2 is 1, plus 1 is 2. So left-hand side equals 2. 4 times 1/2 also equals 2. So this solution checks out. All right. Now let's check the next one. Let's check 5 pi over 3. So I'm going to insert that into our original expression. And we get this. And the cosine of pi over 3 is 1/2. So once again, same thing that happens as up there. The solution checks out. So in this case, the solutions are pi thirds and 5 pi thirds. All right, now we have this example. Now, when I look at this, I see that I have a sine squared and a term and a cosine term. What I would really like to do is to eliminate one of them and put one in terms of the other. And the way I'm going to do that is to use a Pythagorean identity, cosine squared plus sine squared is equal to 1. And I'm going to solve this for sine squared by subtracting cosine squared from each side, and then substituting this 1 minus cosine squared in for the sine squared. All right, so we do this. All right, then distributing the 2, we get that. And now we're going to solve this by factoring. Okay, so we're going to set this equation equal to 0. And then we're going to solve it, we're going to factor it the same way as if this were just an x squared term and this was just an x term. So I'm going to set this equal to 0. Now the way I could do that is to subtract 1 from each side. That would make the right-hand side 0. But I'm going to do something different because I like to have the leading edge of the squared term, which is right now -2. I would like to make that positive, just because I like it doing it that way. So instead of bringing the 1 over to the left, I'm going to take all this stuff and I'm going to move it over to the right-hand side so that this -2 cosine squared becomes a +2 cosine squared. All right? And the way I'm going to accomplish that is by adding the negative of each term on the left-hand side to each side. All right? And then it's going to cancel out the left-hand side to become 0. And then the right-hand side will become 2 cosine squared of x minus cosine of x minus 1. All right? I'm actually going to flip that around and write it like this. Okay? And so we need to factor this. And we factor this by any method of factoring that you like. I like doing it this way since we have 2 here. I want to have factors of 1 and 2 there, and factors of -1 are 1 and -1. And then these multiply, all right, and then those products add to a -1. So, and I can accomplish that by having this combination because 1 times 1 is +1, 2 times -1 is -2, 1 and -2 add to a -1. So this is a combination that I want, all right? And then it's going to be written as this: 1 cosine of x, 2 cosine of x, and the 1 cosine of x gets paired with the +1 of the constant term, so that's an outer. The 2 from the 2 cosine of x gets paired with the -1, that's an inner. And so it becomes this combination. All right, so however you factor, you should end up here. Okay? Then we're going to separate each of these and set them each equal to 0 and solve them, each of them in turn. So for this one, I'm going to add 1 to each side to get cosine of x is equal to 1. And then the angle whose cosine is 1 is x equals 0. So that's a possible solution. And then solving this one over here, subtract 1 from each side, divide by the 2, and then the angle, or angles, in this case angles, whose cosine is negative 1/2, are 2 pi over 3 and 4 pi over 3. So these are the possible solutions for this expression. All right, let's check this solution. Let's check x equals 0. All right, so I'm going to put in 0 for x and then evaluate this. Now note, the sine squared of 0, that's really the sine of 0 squared. We have to remember that. All right, and then the sine of 0 is 0, and the cosine of 0 is 1. And 0 squared is 0, times 2 is 0, plus 1 is indeed 1. So this solution checks out. Okay, now let's check 2 pi over 3. Inserting the value there, reminder that. And the sine of 2 pi over 3, which is in the second quadrant, it has positive sines and negative cosines. So we get root 3 over 2 squared. And we're going to square the root 3, and we're going to square the 2. And that becomes 3/4. 2 times 3/4 is 3/2. And then plus the negative 1/2 will yield 1. And so that's a solution also. All right, one more to check, and that's 4 pi over 3. Okay, reminder of that. And now we are in the third quadrant where both sines and cosines are negative. Okay, so we're going to square negative root 3 over 2. Everything gets squared, including the negative. So negative times negative is positive. Root 3 squared is 3 over 2 is 4. So we get 3/4 there once again. 2 times 3/4 is 3/2. And then plus negative 1/2 once again equals 1. So each of these, all these solutions are satisfied. All right, now let's do example number 3. Now I notice that there's a common term, cosine, cosine, in both terms. So I'm going to factor it out. And so I'm going to factor out a cosine, and what's left behind is 2 cosine of x plus 1. Okay, and then I'm going to set each of these equal to 0. Okay, and solve them in turn. So if I say cosine is x equals 0, that means x is equal to 0, either pi halves or 3 pi over 2. Okay, and then if 2 cosine of x plus 1 equals 0, I'm going to subtract 1 from each side, and then divide the 2, and the cosine is negative 1/2 when the angle is either 4 pi over 3 or 5 pi over 3. All right, and now let's check these solutions. So I'm going to plug pi over 2 in for x, first of all, remembering that that's actually cosine of pi over 2 squared. Okay, cosine of pi over 2 is 0. All right, and so 0 squared is 0 times 2 plus 0 is 0. So that solution checks out. Now let's check 3 pi over 2. Plug it in, remembering that that's actually that. The cosine of 3 pi over 2 is 0. The cosine of 3 pi over 2 is 0, so we're going to put 0 in for both. 0 squared is 0, times 2 is 0, plus 0 is 0. So that one checks out as well. So both pi over 2 and 3 pi over 2 are solutions. Okay, now let's check 4 pi over 3. So I'm going to put that and that. And this is in quadrant 2. Okay, and we know that the cosines are negative there. Cosine of 4 pi over 3 is negative 1/2. All right. If I square negative 1/2, I get 1/4. Okay, multiply 1/4, multiply that by 2, and I get a half. And then a half plus a negative half equals 0. So that solution checks out. Okay, let's do example 4. And this expression. Now I see the unknown, so to speak, is this right here. I have to isolate that, okay? And the way I'm going to do that is first subtract 7 from each side. All right, and we get this. And then divide each side by 3. And I get cosecant squared is equal to 4/3. Now, cosecant is one of our sines. So this is going to be 1 over the sine squared, okay? And then I'm going to take the reciprocal of both sides. And when we do that, we're going to get the sine squared is equal to 3/4. All right? And then we're going to square root both sides. And when I do that, I get the sine of x is equal to plus or minus root 3 over 2. Okay? And now the possible angles for this. Well, if the sine of x is positive root 3 over 2, then x can be either pi over 3 or 2 pi over 3. If the sine of x is negative root 3 over 2, then x can be either 4 pi over 3 or 5 pi over 3. All right, and these are the possible solutions which we're going to plug into here. But it's a cosecant. So I'm going to find the cosecant of these before we plug them in. All right. Now, if the sine of x is plus or minus root 3 over 2, then the cosecant is the reciprocal of that, or the reciprocal of plus or minus root 3 over 2. All right. And then I can take the denominator of the denominator and bring it back on top. So I get plus or minus 2 over root 3, which we don't want to leave a radical in the denominator, right? So we're going to multiply top and bottom by root 3. And the cosecant of x then becomes plus or minus 2 root 3 over 3. And this is what we're going to use in our expression to check. Okay, let's first check pi over 3. Okay, now the cosecant of pi over 3 is positive 2 root 3 over 3 because the sign is positive, right? And so we're going to insert that into here, remembering that this really is the cosecant squared, right? And then I'm going to put 2 root 3 over 3 in for that, okay? And we're going to square all that. Now we have to square everything inside the parentheses. We have to square the 2, we have to square the root 3, we have to square the 3. And so that's going to become 4 times 3 over 9, okay? Which is 12 over 9. Multiply that by 3 to get 36 over 9. And 36 over 9 is 4. And 4 plus 7 is 11. So that solution checks out. And since the cosecant of 2 pi over 3 is also 2 root 3 over 3, this will check also. So I don't need to do this same calculation again. Okay, let's check 4 pi over 3. Now the cosecant of 4 pi over 3, which is in quadrant 3, is negative 2 root 3 over 3 because the sign is negative. Okay, and so we're going to insert that into our expression. Okay, and we get this. Now we're going to square everything inside there, including the negative sign. So the negative sign, negative times negative is positive. And so the net result of that is we get the same thing we got before, 4 times 3 over 9. Multiply by that by 3, and you get 4. And 4 plus 7 is 11. So they all check out. And then, because the cosecant of 5 pi over 3 is also negative 2 root 3 over 3, it will check for that also. So all 4 solutions are valid solutions of this expression. Cosecant of x minus cotangent of x is equal to 1. The cosecant is 1 over the sine, and the cotangent is 1 over the cosine. Now, notice I have common denominators on the left-hand side, so I'm going to write the numerators over that common denominator to get this. And now, I need a way to eliminate one of these and put them in terms of the other. And to do that, I'm going to take advantage. Oh, first of all, I'm going to get rid of the denominator by canceling that out, and so I get this. Okay. Now, I want to have a way to get from the cosine to sine 1, write one in terms of the other. And my go-to for that is this Pythagorean identity right there. Okay? But before I use that, I need to square both sides. Okay? So I'm going to square both sides, and I'm going to get 1 minus cosine of x quantity squared equals sine squared of x. And then I'm going to substitute in 1 minus cosine of x for that. 1 minus cosine squared of x, that is. At the same time, I'm going to square the left-hand side. Square the first, double the product, square the last, or box method or FOIL or whichever method you want, and you get this. Okay? And now we're going to set this equal to 0. Okay? And then factor. Okay, so we're going to set it equal to 0 by taking all this stuff, adding the opposites to get it away from the right and put it on the left. And notice over here I get 2 cosine squared of x minus 2 cosine of x, and the constant terms cancel out. So I get this. All right. And then I'm going to factor this out. So I see a common factor of 2 cosine of x. So I'm going to factor it. And I get this. All right, now I have a product equal to 0, so I'm going to separate it, solve each one. Divide out the 2, and you get cosine of x is still 0, right? And so x is equal to either pi over 2 or 3 pi over 2. Or the cosine of x is equal to 1, and the solution for that is x equals 0. Okay, let's check these. Let's check pi over 2. So I'm going to put pi over 2 in my original expression. All right. Now, over in the margin, I have to find the cosecant of pi over 2 and the cotangent of pi over 2. The cosecant is 1 over the sine. The sine of pi halves is 1, so the cosecant is 1. The cotangent is cosine over sine. The cosine is 0. The sine is 1, so that is 0. And then plugging them in over here, I get that. 1 minus 0, which is indeed 1. So that solution checks out. Now, let's check 3 pi over 2. All right. So I'm going to get the cosecant of 3 pi over 2, 1 over the sine of 3 pi over 2. Sine of 3 pi over 2 is negative 1, so that becomes negative 1. The cotangent, the cosine of 3 pi over 2 is 0. The sine is negative 1, that becomes 0. And then plugging the values over here, I get negative 1 minus 0, which is not 1. It's negative 1. So this does not satisfy this expression, so